And Luann, welcome to the Woman to Woman Show. We have a great show planned for you. We have our special guest today, Gayle Atteberry, the Executive Director of Oregon Right to Life. And we're here to talk about cloning and stem cells. And we're going to get a real education because I know I need one. And welcome, Gayle.
Hi, Luann.
You know, it's so funny. I know everybody out there is used to seeing Christopher Reeve, Michael J. Fox, out there making a lot of news about this subject, and the public doesn't get the whole story.
No, they don't. And
what's going on?
Well, a lot is going on. I find this whole subject of embryonic stem cell research and cloning fascinating. I'm not a scientist, but I have learned about these subjects, and they're not as intimidating as people are thinking. So don't turn your sets off, people.
Exactly. This is going to affect everybody.
It will affect everyone.
Yeah.
If nothing else, in the voting box. And we do. You know, Christopher Reeves and Michael J. Fox, you've mentioned, are the two public figures that draw a lot of sympathy from us, which they should.
And they have the conditions.
They do, and perhaps some of our listeners have friends that have these type of conditions, and they do draw sympathy from us. They should. How do we try to heal them? Is the big question.
Right.
I'll start from the beginning.
Oh yeah, that's always good because you're right. You know, everybody doesn't have a lot of time, and they're not scientists. And I think the bad guys are taking advantage of that.
They are.
Right?
They are taking advantage of it. And actually, if the listeners will follow real close, I think they can learn now as much as scientists are what they're doing, and they can learn these scientific terms. The first is embryonic stem cell research, which we hear a lot about, and which scientists have made a big hullabaloo about, making promises that are not in the near future anywhere feasible.
About cures.
About cures, yes. And that's where we see Michael J. Fox and Christopher Reeves come into the picture. The thought is that they can take embryonic stem cells and experiment and find cures. What's a stem cell?
Yeah, let's start at the beginning because, you know, up to a few years ago, nobody had even heard of that
I didn't
term.
either. But actually, it's a very simple thing. A stem cell is a cell in our body which is nothing. It's a blank slate. It's not an eye cell. It's not a skin cell. It's not a blood cell. It's a blank cell that it has not decided to be anything yet. Now, scientists want to take these blank slate cells and coax them to be something, such as if, say, you have heart damage, they want to coax the stem cell to become a heart cell to repair our heart.
I think I can kind of follow that.
Okay, or if they have, say, in case of Christopher Reeves, where there's spinal injury, to coax the stem cell to become a spinal cell, which would then repair the spinal system.
Got it.
So that's what they want stem cells for. Now, one rich source of stem cells is the embryo. And not just any embryo at any age, but an embryo at 5 days old, 5 days after conception. Very, very tiny. We all know, scientists know, the medical community knows, that human life begins at conception. At the moment the egg and the sperm unite, you have a brand new human being. From that point, this human being...
This is no religion coming into anything.
No, nothing at all.
This
is just science.
Okay.
And from that moment, that human being, very, very tiny, starts to grow.
Which we all were.
We all were, and we all are, all of us are in one stage or another of growing.
Yeah.
Some of us are growing old.
I love that. It's the kind that doesn't need the wrinkle cream yet.
That's right.
Right? Okay, got it.
So from the moment of conception, this embryo starts to grow. And at 5 days, when the embryo is 5 days old, it's called a blastocyst.
Okay.
That's the name of an embryo at 5 days.
Scientific term.
That's the scientific term. Now, that's the stage that scientists want embryos, because at 5 days, the blastocyst is filled with stem cells. And that's all there is in it at 5 days.
Okay.
Now, in 3 or 4 days, those stem cells are going to start becoming something. They're going to start becoming brain cells, blood cells,
so it's a
skin cells.
time-sensitive
That's right.
thing.
So they have to get them at day 5 or 6
Day
at the
5
latest.
or 6.
And so scientists, researchers want to get the blastocyst, break into it, take out the stem cells, and experiment with them. Well, in that process, they kill the embryo.
No, 100% will be killed.
Everyone is
no
killed.
way.
There's
okay.
no way
Okay.
other to do that. So that is why a lot of people, way beyond even pro-lifers, there's a vast segment of the nation that says, no, we're not going to kill life, with the vague hope that we can find a cure.
Which has never been done
It's
before
never been done.
with embryonic stem cells.
No.
And I know in the news, I notice a lot of the newscasters are just saying stem cells when they mean embryonic, and this is so wrong.
I know
and
it.
the people, and I
It's
get so
confusing.
mad. I'm yelling in my living room. That's not right. And you know, I wonder sometimes if they even know themselves, and the reporters writing
I'm not
up the
quite
thing.
sure the journalists
I don't know.
always know,
I
but
don't
we
know,
get all
but
confused in
it's
the process.
Wrong, whatever
Yeah.
it is. And no cures.
That so
Okay.
far they've been experimenting with about 8 or 10 years with embryonic stem cells. Not one even animal has been cured.
I didn't know that.
Not even an animal. And so they have not progressed to the human testing stage because they haven't passed a couple of the problems with embryonic stem cell research. The main problem being is that the embryonic stem cells, when implanted into an animal, causes tumors.
Oh, right.
Yeah.
And cancer.
And yes, some of them are cancerous, some of them
big-time
aren't malignant, are not, but they're tumors. Because as we look at it, embryonic cells are programmed to grow very fast.
That's right.
Because your baby is well formed by 6 weeks. So these embryonic cells grow fast.
Okay.
Well, when you put them in animals, they grow fast and they
Right.
form tumors. So that's the main problem that they have not overcome yet.
So that's going to lead us to the other C word.
That's right, the C word.
And I know we've just got a little under a minute left, and we have to talk about this when we're going to watch a video.
And then we'll come back and talk about that. There's one other reason that leads us into cloning, and that is, and I hope you address it in another program, there are not enough leftover embryonic or embryos to experiment with to get the cells out. So that there's not enough of them, and so the scientists want to make their own, and they make their own by cloning.
And this is happening. This is what they're after, and we're going to talk more about this because this is what affects us all. This is just plain wrong.
That's
right. But the video is great. Let's
look
watch
at the
video, and then we'll be back. Thanks.
The stem cell debate is filled with controversy, questions, and confusion about science, cures, and how we should treat human life at every stage.
While we prolong the stem cell debate, millions continue to suffer.
And stem cell research offers hope of a cure.
The embryonic stem cell fervor, I guess is the word I'm looking for, has blinded people to what else is available.
And as an individual with a disability, I don't want precious resources that could be dedicated to adult stem cell research to be diverted into very iffy and not very promising embryonic stem cell research.
How the people of Michigan resolve the stem cell debate will impact countless lives, not only patients seeking cures, but young human beings some want to destroy, searching for those cures. It's time to learn the facts. The science of stem cells, finding cures, and protecting life. Viewed through the microscope, stem cells don't look like much. But stem cells are remarkable building blocks of the body that can repair or even replace damaged tissues and cells. There's a rich supply of what's called adult stem cells found throughout the body, in bone marrow, fat tissue, even the amniotic fluid that surrounds and protects unborn babies. One of America's leading adult stem cell experts works right here in Michigan at Wayne State University School of Medicine. The focus of Dr. Jean Peduzzi Nelson's research is learning how adult stem cells can be used to help paralyzed people walk and function normally again.
Actually, it's not the focus of my life, it's the obsession of my life. My obsession is to get a treatment out there for the patients that have severe chronic spinal cord injury. And this is what I've been doing for the last 15 years.
Her persistence is beginning to pay dividends. Research she's conducting in the lab is helping patients get out of their wheelchairs or do things no one thought were possible.
So far, this treatment has worked better than any other treatment that we have tried. And so I'm very excited about the potential of this.
Many people don't know that adult stem cells are being used right now to help people suffering from all kinds of conditions, including heart disease, sickle cell anemia, multiple sclerosis, and much more.
Pick it up. Pick it up. Let's go. Pick it up.
The healing power of adult stem cells is bringing new hope to spinal cord injury patients like Katie DeHaan and Jenny Rummelt. Tragic car accidents left both Grand Rapids women paralyzed from the waist down. Doctors gave them little hope of recovery. But intense physical therapy sessions combined with a new adult stem cell treatment only available overseas means Katie and Jenny are experiencing real progress.
Just like overall, I was like totally different. I was like 100% stronger in everything I did.
And I mean, it seems like something's always either improving or getting stronger, or I'm feeling different things when I'm putting weight through my legs or weight transferring, and a lot of little things that you wouldn't think about and you would take for granted, I'm able to do now. What is my end goal? Is to walk again.
There are many reasons to be encouraged about adult stem cell successes, but it's another kind of stem cell that gets most of the news media's attention. Embryonic stem cells are harvested from live human embryos, which are then destroyed in the process. Human embryos occur naturally in the marital act, when sperm from a husband unites with the ovum or egg of his wife. It's the beginning of human life. Embryos can also be created in the lab using in vitro fertilization or IVF. One IVF procedure requires a technician to use a needle and inject sperm into a human egg. The new embryo is then implanted into a woman, where it continues to grow until birth. Thousands of extra human embryos are created by the IVF industry, then frozen and stored each year. Some people think we should conduct experiments with them. Some scientists claim embryonic stem cells offer the best hope and promise for finding cures. But there are real scientific problems with embryonic stem cell research that no one seems able to solve. In fact, not one successful cure or treatment has ever resulted from embryonic stem cell research. And scientists now say cures may not emerge for decades, if ever. Embryonic stem cells are unstable and tend to form uncontrollable tumors if transplanted into the body. Experiments also show our body's own immune system may reject these cells if they're used to replace diseased or injured cells. To try and solve that problem and to create still more embryos for use in the laboratory, scientists want to artificially create or clone human